Algebra 3, Chapter 8, Section 1, the Law of Sine. Okay, so we know how to solve right triangles, but what about triangles that are oblique or that have no right angles? Well, we have a couple of laws that will let us solve for missing sides and angle measurements. The first one is the law of sines, and this will work if you're giving any two angles and a side. You have to have a side, and then if you have two other angles, you're good to go. You can find the rest, no problem. You can also find it when you have two sides and the angle opposite to one of those sides, side-side angle. Now, this is kind of a unique case. If you remember when you did congruences in geometry, you had angle, angle, side, you had angle, side, angle. You had side, angle, side, which we'll talk about that one later, but side-side angle never worked, and there's a reason for that. We'll talk about that later. Anyway, here's the law of sines. The law of sines says that the sine of an angle over its opposite side equals the sine of another angle over its opposite side. And you can do that for all three angles and sides. So sine A over A equals sine B over B equals sine C over C, or you can flip all three of them upside down. And let me tell you a little hint. It's easier if what you're solving for is on top. So which do these do you use? You use the one that's going to make it easiest on you. So if you're trying to find a side length, you should use the bottom setup. If you're trying to find an angle measure, you should use the top. You're going to use these two at a time. You'll use one ratio that you have both bits of information for, the angle and the side, and then the other one you'll use where you have one bit of information and you're solving for the other. Okay, now the side-side angle case is tricky. In fact, it's called the ambiguous case, ambiguous meaning not clear, because there are possibly one, two, or no triangles formed with the measurements they gave you. You might be wondering, well, how is this possible? Well, consider a triangle where you're given side A, side B, and angle A. We're going to look at the different possibilities. We're going to fix side B and angle A, and then try to figure out what side A would have to be to make the different triangles. We're going to examine. Now, don't panic on this because it's actually pretty easy to work through these and figure out what you have. But I'm going to show you the different possibilities first. If you have an obtuse angle for A, then side A, the opposite side, needs to be larger than B. Otherwise, as you can see here, it's not going to connect and form a triangle. And if side A is less than the height of the triangle, like we see here, then you're not going to have a triangle formed. So what they did here was they did angle A and B, and then they kind of drew a height. Well, if side A is smaller than that height, you're not going to get a triangle. If the side equals the height exactly, you have one triangle and it's a right triangle. If angle A is obtuse and A is greater than B, you have one triangle. And if A is bigger than the height but smaller than B, and angle A is acute, then you actually have two possible triangles. You can see where the two positions here for side A would be. Now, I know this sounds really confusing. So how do we know what we have? Well, first of all, use the law of sines to find the only angle you can find. You're going to be given an angle and a side opposite and then another side. There's only going to be one angle you can find, so try to find that first. If you get an error message in your calculator because the sign when you go to solve is greater than 1, that means you have no triangle and you're done. If you do get an angle, then you know you have at least one triangle and you can go through and find the remaining information. Now, you do need to find whether or not there's a second triangle and find its information if there is one. How you figure it out is you subtract the angle you got from 180. In other words, you find its supplement and add that to the angle they gave you in the problem. Now, if when you add them together, you get 180 or more, then you're not going to be able to form a second triangle. You only have one triangle and you just need to find that. If the answer is less than 180, you will have two triangles. And that supplement that you found in the first step of this, just above here, for the angle, that supplement is going to be the second angle for that second triangle. So you will have a second angle for the first triangle, a second angle for the second triangle, and then you just find the remaining information. Thanks to our trig functions, we also have a new way of finding an area of a triangle if you know the length of two sides and the angle in between. And we're doing this here because it involves sines. So the area of a triangle is 1/2 BC sine of A, or 1/2 AC sine of B, or 1/2 AB sine of C. Now, which one do you use? Depends on which information you have. You use the one that you have the most information for. Sometimes they might give you one where you don't have all the information you need, and you need to use the law of sines to find the missing information. But basically, whatever you've got the information for is the one you want to use. So let's use the law of sines to solve this triangle. And then there's two actually here. The first problem on the left, they gave you a drawing. The second problem on the right, they give you information. Pause the recording, give it a try, and resume to check your answer. Okay, for this one, we know that we can, angle A has to be 30 because the angles of a triangle must total 180. Then we're going to find side A. We do that by saying A over sine of A, sine of 30, equals B, 20, over sine of 45, and then we solve. We multiply both sides by sine of A, sine of 30, and we get 14.14. And then we do the same to find this side C. That should be a lowercase c. Please remember that you cannot use Pythagorean theorem on this because this is not a right triangle. For our second triangle, angle C is 80 degrees, and then we do pretty much the same thing we did before to find sides A and B. Okay, now try this one. Use the law of sines to solve it, and round your answer to 2 decimal places. Pause the recording, give it a try, and resume to check your answer. Okay, here we go. Again, you can see the procedure for doing that. What they did is they actually solved for sine of A. And you can do that as well. Put the numbers in. Notice if the given angle is in degrees and minutes, then our answers also need to be in degrees and minutes. So we find the remaining angles and then the remaining side. Okay, here's another example. We're going to use the law of sines to solve. If there are more than two, if there's more than one, if there are two triangles, find both. Pause the recording, give it a try, and resume to check your answer. So solving for B, we get 48.74 degrees. Angle C is 21.26 degrees, which gives us 48.23 for side C. On our second example, you can actually kind of play with this. This is an isosceles triangle because sides A and B are the same, which means angle A and B are going to be equal. So if A and B are both 45, C has to be 90. We've got a right triangle here. So really, you can use the facts we know about right triangles to find our missing side. It's 1 square root of 2. All right, pause the recording, give this one a try, and resume to check your answer. All right, so first of all, we solve for angle B, and we get 72.21 degrees. Subtracting that from 180, we get 107.79 degrees. If we add that to 58, it's less than 180, so we actually do have two triangles here. So we'll notice we've got case 1, that's where B is 72.21. Case 2 is where angle B is 107.79. The rest of it's going to be just like we do everything else, except you've got two triangles to go for. Find C for both, and then side C for both. All right, now we're going to use our area formula. Find the area of the triangle having the indicated angle and sides. Pause the recording, give this a try, and resume to check your answer. Okay, here we're going to use 1/2 AB sine C, and just throwing in the numbers, we get 10.4. For our second one, we'll use 1/2 BC sine of A, and we get 1,675.2. Okay, let's do a Application problem. Because of prevailing winds, a tree grew so that it was leaning 4 degrees from vertical. So you can see the diagram there, and instead of 90 degrees, it's making a 94-degree angle. At a point 40 meters from the tree, the angle of elevation to the top of the tree is 30, and you can see all that marked on the triangle there. Find the height of the tree. So you are going to be using the law of sines. You'll need to find your third angle first, and then use the law of sines to find h. Pause the recording, give it a try, and resume to check your answer. So angle C is 56 degrees. So we will do h over the sine of 30 equals 40 over the sine of 56. Multiplying both sides by the sine of 30, we get 24.1 meters. Okay, so we have angles elevation, theta and phi, to an airplane from the control tower and from an observation post 2 miles away. If you look, you see the triangles drawn there. They want you to write D in terms of those two angles. D equals what in terms of those angles? It would be very helpful if you would remember the relationship between exterior angles to a triangle, which is what phi is, and the remote interior, the ones on the other side from it. And you can use that to help you in this. So pause the recording, give it a try, and resume to check your answer. Okay, so they redrew it, and notice we got alpha. Alpha is in the upper corner there, and they said that is 180 minus theta minus 180 minus phi. That angle on the inside is the supplement, angle B there at the observation post is the supplement of phi, so its measures 180 minus phi. And when we simplify that, we get phi minus theta, so that's what angle alpha is. So using that, the distance over sine of theta is 2 over the sine of alpha, and there you have it. Distance equals 2 sine alpha over sine of phi minus theta.